Hello, welcome back. This video we're going to be looking at dot point 7.1, which is the name and structure of hydrocarbons based on IUPAC nomenclature. The reason why we're looking at this first is if you watch the introduction video, we want to know what does propene mean, like what is propene. Now, the reason why I use the term propene and not propylene, which is the name that you see in the material list for the N95 mask, is because propene is actually the official IUPAC nomenclature of the substance. And the way that an IUPAC nomenclature works is it allows you to know exactly what substance it is just by looking at the name. So in this video and also the next one, we're just going to look at IUPAC nomenclature and how to read it before we're going to do any actual production of N95 mask. Okay, so IUPAC is the International Union of Pure and Applied Chemistry, and this is an organization that was established in around 1919, and it's still present. I think the headquarters is in Paris. And the main function of the IUPAC is to establish some consistency when it comes to chemistry. And that has to do with everything from the way things are named to what is the acceptable mass of something, what is the acceptable definition of any concepts that has to do with chemistry. And the main reason for doing that is just so that we have some consistency when it comes to international collaboration, and so people understand what they are talking about if they come from different background. We're going to look specifically at IUPAC nomenclature. Now, I will probably going to use the word nomenclature and name interchangeably, but the difference between an IUPAC nomenclature and just any regular name is this is a systematic name. So I'm not naming it because I'm not going to name, say, this molecule Bob because it reminds me of a Bob. No, an IUPAC nomenclature is a systematic way, and you're going to name every molecule in a way that when you look at the name, you know exactly what the structure is. So the true test of an IUPAC nomenclature is if I name it, I can draw the structural formula correctly. So that's IUPAC nomenclature. Now, these are the steps for naming an organic molecule using IUPAC nomenclature. We're going to go through every single step, but my recommendation is either if you have a printer to print this slide out, I think there's going to be like a PDF of it, or you can write the steps down because we're going to continuously refer back to this particular set of steps. If I was in class, I would have printed it out for you, but anyway, so there are 5 steps. We're looking at suffix, stem, prefix, carbon in the stem, and then you have the full name. So let's just start with what I mean by suffix, prefix, and stem. So these are some examples of IUPAC nomenclature. So propene, ethene is another one. I don't know whether any of you have heard of the term ethene. I might talk about Pantene, the shampoo, later. Ethanol is another IUPAC nomenclature, pentanoic acid, 2-hydroxy-pentanoic acid. So these are examples of IUPAC nomenclature. At the very least, every IUPAC nomenclature or IUPAC name must contain the stem and the suffix. And sometimes they have the prefixes as well. So the suffix, let's just change the color. So the suffix is the last part of the name because it's a suffix. So in the case of propene, the suffix is actually ene. And then that's another suffix. So the first 2 names here indicate that the molecules have something in common because they have the same suffix. And then this one has a suffix of ol. The suffix on this one is actually oic acid. And then this one's also oic acid. So these 2, the last 2, have something in common. So that's the suffix. The next part on the name is the stem. So the stem is here. So this name only has the stem, and the suffix doesn't have a prefix. You will know what part is which. It takes a lot of practice, but eth is actually the prefix here. So we'll talk about the an next year, maybe. And then pent is the suffix here. And then this one, sorry, not the suffix, the stem. This one, the stem is pent. And the only name out of all these examples that actually has a prefix is this the last one. So 2-hydroxy is actually a prefix. That color is not the same as the other color, and somebody's gonna comment on it, so I'm gonna try. All right, that's better. So 2-hydroxy. I don't think these two colors are the same either. Are they the same? No. I can't even tell. All right. So 3 parts: suffix, stem, and prefix. Okay. Let's start with the suffix. The suffix in IUPAC nomenclature is essentially a group of letters which is used to indicate the type of bonding and or atoms present in the molecule. So by looking at the suffix, you should be able to tell what kind of atoms are present and what kind of bonding is present. For this year, and I see how much time I have, I'll probably go back to this and talk about other suffixes. By the end of year 12, there are 11 suffixes, I think, maybe 12, that you have to know. But we're going to start with the first 3, which are ANE, ENE, and YNE. So N, in, and I. Now, these suffixes are for hydrocarbons. So when you see either of these 3 suffixes, the first thing that you should be able to deduce is that these are hydrocarbon. Now, a hydrocarbon is an organic compound that contains only hydrogen and carbon. Duh. So, organic compound, let's write that. Organic compound containing hydrogens and carbon. Okay. So if you see these 3 suffixes, the first thing that you should be able to get out of it is that this is a hydrocarbon, this is an organic compound that contains hydrogen and carbon, and there will be no other types of elements present beside carbon and hydrogen if this is a suffix. All right, let's start with the N. Any molecule that ends with N, it's an alkane. So that's the name, the family name. So an alkane is essentially a family of hydrocarbons. So still only contains carbon and hydrogen, but it only has single carbon-carbon bonds. So something like this. Well, this one doesn't have any carbon-carbon bonds, but you still consider it to be an alkane. This is CH4, and then the next one, so this is another alkane. You only have single carbon-carbon bond, and obviously you will still have single carbon-hydrogen bond. And then there's this one, and then there's this one. So these are examples of alkanes. Okay. Alkene is any molecule that ends with ENE, and these are some examples of alkene. So essentially when you have an alkene, it is a family of hydrocarbons that contains at least one double carbon-carbon bond. So you're going to consider this to be an alkene because the only carbon-carbon bond present is a double bond. Now this molecule actually has a single bond and then a double bond. So whenever there is a double bond present, you're going to consider it to be an alkene and not an alkane. So you only call something an alkane if the only bond present is carbon-carbon single bond. As soon as there is one double bond present, it becomes an alkene. Okay. And then lastly, we have alkyl. The suffix is YNE, and that is when you have at least one triple carbon-carbon bond present. So if something, the way that it works is if you have triple bond, that will take higher priorities, followed by double bond and followed by single bond. So if you have one triple bond present, that's an alkyl, regardless of whether or not the remaining bonds are single. Okay. So 3 suffixes: N, in, and I. All right, so let's start with this. So this will be an alkene, and then so this only contains carbon single bond, so that's an alkane. I probably should write it out somewhere. Okay, let's try again. So number 1 is alkene, and number 2 is an alkane. Number 3 is an alkyl because you have a triple bond or 3 covalent bonds. Number 4 is also alkane. If you don't have any double or single or triple bond, then it will be an alkane. This is an alkyl. There is a triple bond. How many of these do I have? Okay, alkane again. and then that's a alkene. Oh, that's it. All right. So that's the distinction between alkane, alkene, and alkyl. I think I'm going to stop here